So the general senses, or what you've mostly learned as the sense of touch, is widespread throughout the body. So every part of your body can feel touch and vibration and pain. And the receptors are generally very simple. We have two main kind of receptors. There's unencapsulated. So these are nerves that do not have any myelin capsules around the endings. And there's a few types of these. So free nerve endings are typically warm-cold receptors as well as pain receptors. You can actually feel these on your skin if you take a number 2 graphite pencil and run it slowly along your arm. Anywhere where it starts to feel cold, that's a free nerve ending. The tactile discs, these are in the base layer of the epidermis, and these are generally sensitive to light touch, so feeling different textures or edges of shapes. And then hair receptors. So these wrap around the follicle of a hair. So when some kind of insect bends the hair, it bends the nerves, and that sends a stimulus to your body. These adapt very quickly, otherwise you would constantly feel all of the clothes on your body. These are super important for eyelashes to help us blink to prevent things getting into our eye. So encapsulated nerve endings, you can see, are surrounded with these myelin capsules. So the dendrites here are surrounded by this insulating fibers. There's a few different types. So tactile is going to be associated with light touch as textures. Again, this is linked to the edges of your dermal papilla. So here's the dermal papilla. And these are commonly found in the fingertips, palms, eyelids, lips, nipples, and genitals. So if you were to feel two different textures like silk and sandpaper, this is generally what's going to help you feel that difference. We've got end bulbs and bulbous capsules. So end bulbs have light touch and another texture, but these are found in mucous membranes rather than in the skin. So this would be things like your lips, tongue, the conjunctiva of your eye. The bulbous corpuscles are going to respond to heavy touch. So this is the pressure of stretching the skin. If you bend your fingernail, this would be a heavy touch. Feeling the general shape of objects rather than just the texture or edges. And then lamellar is down here. Lamella is kind of when lines lay flat like that. That's how this gets that name. Is generally going to be sensing vibration. So this is found deep in the dermis or in the periosteum of bones and in joints. One of our other general senses is the sense of pain, which is also kind of a touch. So pain is really a necessary sensory system because even though it's a discomfort, which is caused usually by injury or noxious stimulation, this is going to lead to evasive action. So if you don't know that there's something wrong, you don't know to take care of it. So pain tells our body there's something wrong here, and that gives our body an opportunity to fix it. If it's an injury, we can go address the injury. If it's something internal, we can go to the doctor and get it diagnosed. So without pain, we would never know that there was a problem. There's two speeds to pain. Pain can be fast, which is kind of a sharp, localized stabbing pain. So like this person who's pressing on this tack, if they press on the tack, they will immediately feel pain. And it's very fast because those are myelinated, which means that the action potential is going to move very quickly. And then usually after you injure yourself, the initial pain goes away with the stimulus, but there's usually a longer, duller, kind of more diffuse pain. And that's from the same stimulus, but it's running along unmyelinated tracts, so those are a little bit slower. A pain projection pathway is typically 3 neurons long, so 1, and then 2, and then 3. And this is going to go from the stimulus to the spinal cord, all the way up the spinal cord to the brain, and then in the brain to a somatic sensory association area, depending on where that sense is coming from. And these pathways can be very complex. So oftentimes we have what is called referred pain. And this is where pain from our visceral organs gets mistakenly referred to kind of our skin or other superficial areas. So a really good example of this is often left arm pain is referred pain that actually indicates a heart attack. So it's actually pain being sensed in the heart, but we feel it in our arm. And this is because there's a convergence of these neural pathways. So the cardiac neural pathway converges with the chest and the arm at about T1 through 5, and then the brain has to interpret that. So oftentimes feeling pain somewhere might be a good indicator that there's actually an internal issue, and so sometimes constant or chronic pain is a good reason to go to the doctor. Our central nervous system has methods of dealing with pain. So it has analgesis, which is a method of tempering pain and pain relief. It can also tell our body to release endorphins, which are a natural opioid. So this is what happens when you get a runner's high, or if the body's in a high stress situation like childbirth, it might release endorphins to help you deal with the pain. So take a moment and reflect on why pain is actually an adaptive benefit.